Proving identities is one of the most challenging concepts in all of AS level, and if you're watching this video, you've probably had an identity crisis. But don't worry, by the end of this video, you'll find yourself. I'll show you the patterns to look out for, and I'll give you the exact blueprint to solve literally any identity problem. And if I fail to do that, then you probably need to see a therapist. But jokes aside, subscribe and let's get into it. At AS level, we're given two identities to work with, so that sine theta over cos theta is identical to tan theta, and sine squared theta plus cos squared theta is identical to 1. So the first identity, tan theta equals sine theta over cos theta, we usually use it in this exact form. But for the second identity, we can rewrite it in two other forms, which are sine squared theta is identical to 1 minus cos squared theta, and cos squared theta is identical to 1 minus sine squared theta. The general principles that you should follow when you're proving identities is that you should work from the more complex side to the less complex side, reduce anything in terms of tan x to be in terms of sine x and cos x. So that means we're using the identity tan theta is equals to sine theta over cos theta, and if you have any separate fractions, combine them into one single fraction. And of course, the last tip is that you should expose yourself to a lot of trig identity questions. The more questions you do, the more familiar you'll be with the different types of trig identity problems, and the easier it will be for you to prove them. So let's look at some past paper trig identities. So number 1 here says show that sine theta plus 2 cos theta over cos theta minus 2 sine theta minus sine theta minus 2 cos theta over cos theta plus 2 sine theta is identical to 4 over 5 cos squared theta minus 4. So we want to work from the more complex side to the less complex side. So in this case, that means we're working from the left hand side to the right hand side. And as you can see, on the left hand side we have two different fractions, but on the right hand side we have one fraction. So what it means is that we're going to have to combine these two fractions to give us one fraction. So let's do that. If you combine the two fractions, you end up here, and if you simplify further, you end up here. And then here we can use the identity that sine squared theta plus cos squared theta is identical to 1 to replace this. So as you can see, that now becomes 1. If you simplify your numerator, you then end up with 5 sine theta cos theta plus 2, and then simplify that, and you should end up with 5 sine theta plus 2 minus 5 sine theta cos theta over cos theta minus 2 sine theta times cos theta plus 2 sine theta. And if you simplify that, your numerator will simplify to give you 4. Then now let's work on the denominator. And what we've simply done here is we've expanded the denominator. So we say cos theta times cos theta to give us cos squared theta, cos theta times 2 sine theta to give us 2 sine theta cos theta, minus 2 sine theta times cos theta to give us minus 2 sine theta cos theta, and minus 2 sine theta times 2 sine theta to give us minus 4 sine squared theta. And we simplify our denominator, and we end up with 4 over cos squared theta minus 4 sine squared theta. And now we rewrite sine squared theta in terms of cos squared theta using the identity sine squared x is identical to 1 minus cos squared x. So that becomes cos squared theta minus 4 times 1 minus cos squared theta. And we should be able to simplify and get back the right hand side, and so we have proved our identity. So as you can see, the general principle here is that on our left hand side we had two fractions which we combined into one fraction, and we continued to simplify until we got to the right hand side. So now let's move on to the second identity. 1 plus sine x over 1 minus sine x minus 1 minus sine x over 1 plus sine x is identical to 4 tan x over cos x. Again, you can see that we have two fractions on the left hand side and we have one fraction on the right hand side. Our more complex side is the left hand side, so we're going to work from the left hand side to the right hand side. Since we have two fractions on the left hand side, we'll combine them to form one fraction. And if you combine, you get to this stage here, and from here we'll expand our numerator, and you should end up with 4 sine x over 1 minus sine x times 1 plus sine x, and in the denominator we have a difference of 2 squares, which simplifies to 4 over sine x over 1 minus sine squared x. And using the identity cos squared x is identical to 1 minus sine squared x, we can rewrite our denominator as cos squared x, and now we have 4 sine x over cos squared x. Then we can rewrite this as 4 sine x over cos x times 1 over cos x, which allows us to use the identity tan x is identical to sine x over cos x to substitute this here, and you end up with 4 tan x times 1 over cos x, which is the same as 4 tan x over cos x. And that means we have proved our identity. Now let's move on to our third identity. 1 minus 2 sine squared theta over 1 minus sine squared theta is identical to 1 minus tan squared theta. So in this case, it's debatable as to which side is more complicated. Some will say that the left hand side is more complicated, some will say that the right hand side is more complicated. So you can work from either side. But since there's a tan squared theta on the right hand side, I would prefer to work from the right hand side to the left hand side to simplify the tan squared theta so that I end up with a sine squared theta at the end. So let's work from the right hand side to the left hand side. So we're going to use the identity tan theta is identical to sine theta over cos theta. So we had 1 minus tan squared theta, and that has now become 1 minus sine squared theta over cos squared theta. And now in this case, what we have done is we've rewritten 1 as cos squared theta over cos squared theta minus sine squared theta over cos squared theta. And now since they have a common denominator, we've combined them, and it's become cos squared theta minus sine squared theta over cos squared theta. And then we're going to use the identity cos squared theta is identical to 1 minus sine squared theta in our numerator, and this now becomes 1 minus sine squared theta. And if we simplify, we end up with 1 minus 2 sine squared theta over cos squared theta. Then again, in our denominator, we will use the same identity. Cos squared theta is identical to 1 minus sine squared theta, and you end up with 1 minus 2 sine squared theta over 1 minus sine squared theta. And now we have fully moved from the right hand side to the left hand side, and we've therefore proved our identity. Now let's look at one last identity. Sine cubed theta over sine theta minus 1 minus sine squared theta over 1 plus sine theta is identical to minus tan squared theta times 1 plus sine squared theta. Again, you could work from either the right hand side to the left hand side, but since I have two fractions on the left hand side, we'll work from the left hand side to the right hand side. So in this case, you notice that on the left hand side we have two fractions, but on the right hand side we have one single term. So we'll start off by combining these two fractions to form one term. So if you combine them, you end up with this expression over here: sine cubed theta times 1 plus sine theta minus sine squared theta times sine theta minus 1 over sine theta minus 1 times sine theta plus 1. And if you expand your numerator and you simplify it, you should end up with sine to the power of 4 theta plus sine squared theta over sine theta minus 1 times sine theta plus 1. And now let's factor out sine squared theta in the numerator. Now let's expand our denominator. You notice that this is a difference of two squares: sine theta minus 1, sine theta plus 1. So if you expand it, you get sine squared theta minus 1. And from there, we're going to use the identity sine squared theta is identical to 1 minus cos squared theta to substitute this sine squared theta over here with 1 minus cos squared theta. And then if we simplify our denominator, it becomes minus cos squared theta. And now we can say that sine squared theta divided by cos squared theta is identical to tan squared theta. And so we have therefore proved that the left hand side is identical to the right hand side. So that's it for today's video. Thank you for watching. If you liked it, subscribe for more videos like this.